Hello, welcome to Gradeup. Today we are here for control system sessions. Okay, I'm waiting for more viewers to join. So, in control system there are very important topics, and it is a very easy portion of GATE as compared to others. Okay, and for basic electrical engineering and also the students of ECE, okay, the control system is very much scoring because the questions are very easy, and also the questions are from a very specific domain. Like we can have signal flow, the signal systems, the signal flow graph is very common, and also in transient time response, the steady state errors and the error coefficient calculations, those are very common. And in frequency response, the Nyquist and the route, okay, root locus, and we also come across Bode plot. Bode plot is very much asked, and it is asked in different fashions. Okay, by magnitude it is changed into decade to octave. Okay, so these are very well known questions from this which occur always. Okay, state space analysis, controllability and observability is also very common in this. So the first question which appears, "58 viewers." Okay, so I think that it's time to start. Let's start, then we can have discussions in between about what to prepare and how much to prepare. A lead compensator, the first question which is on your screen is, a lead compensator network includes a parallel combination of R and C in the feed forward path. If the transfer function of the compensator is given, then find the value of RC. RC, that is the time constant. Okay. So R2, R1, C1. Okay, there is C. So it is R and C are in parallel combination. It will be of lead compensator. Okay, if it is like this, that R1, it is R2, and it is C, then it will be of lag compensator. Okay, what is the speciality of lead and lag compensator? In lead compensator, the zeros will be nearer to the origin, okay, and the poles will be far from the origin. Same as in lag compensator, the poles are closer to the origin and the zeros are far from the origin. Okay, so the lead compensator improves the steady state response of a given system, and the margin of stability increases. It is high pass in nature, bandwidth increases, signal to noise decreases. Okay, so we should begin with the question. 0.5. Yeah, 0.5 is the correct answer. Okay, so the lead compensator alpha TS plus 1 upon alpha TS plus 1. So the equation was S plus 2 upon S plus 4. So S by 2 plus 1 upon S by 4 plus 1. It will be half. From this, alpha will be equals to 1 by 2. And from this term and this term, T is equal to 1 by 2. And T is the time constant. T is the time constant, is equal to RC, R1C in fact. Okay, it is 1 by 2 is equal to 0.5. So Omkarnath Jha, very good, and Purushottam Jha also very good. It is 0.5. Okay, it was basic question to let you enter into the today's topic of discussions. Okay, likewise you can have lead and lag compensators when it is the questions are asked. So the frequency of at maximum phase, that will be equals to root of AB, where A and B, okay, A may be the zeros and B may be the poles, or A may be the poles and B may be the zeros, okay. The frequency of maximum phase at which occurs, the maximum phase frequency will be given by this. So come to the next question. A unity feedback control system. The question is on your board. Please go through it and try to answer. Hope the preparations are going in full swing. And you have to attempt a good number of questions in GATE, because in ECE and electrical, the cutoff for PSU, the call letter for which you are eligible for PSU interviews are very high. So you have to put in a lot of efforts. Okay. Second question is on your screen. Try to solve it and answer it. See, in control system, the questions are very monotonous type, means you have to solve them by a given pattern only. Okay. A unity feedback control system requires 0.52 seconds to reach its peak value. Okay. For peak, it will be n pi by omega d, where n is equal to 1 for first peak. Suppose if it is the response, so n will be 1 for this point, n will be 2 for first undershoot that is going to occur, n will be 3 for second overshoot that is going to occur. Okay, so Tp is equal to n pi by omega d, that is known to you, 0.52 seconds. Okay, and the settling time for 2% tolerance criteria, okay, it is 4 by zeta omega n, and that is known to you as 1.05 second. Okay, so you, for the calculation of 5, okay, no, actually it is very close to, it was previous, Vishal Raj, you answered correct. The next question which appears on your screen is, you have to answer for it, okay. It is for omega r, that is the resonant frequency. What is the resonant frequency? For omega r, we have to calculate natural frequency. This is the formula, okay. And with the help of this formula of peak time and settling time, we have to calculate zeta from that place, okay, and we have to calculate omega n value. So how are we going to proceed it? We are having Tp by Ts, okay. We can have these both set of equations are known. So actually Tp by Ts, we can rather substitute the values. N is equal to 1 for first peak time, means first overshoot it is saying, okay. So it will be pi by omega d, okay, and Ts value is 4 into zeta omega n. Omega d, again it is known, omega n root 1 minus zeta square, standard second order equation. And damping frequency, damped frequency is natural frequency into that formula. So from this we can have 0.52, 1.05, and zeta comes out to be, see, the questions will be of this type only, means the proper set that you have to follow will be the proper equation, and the proper steps are this only, okay. You have to practice a lot, especially when it is of GATE, because the calci which you have to use is virtual calculator. You have to practice more on the virtual calculator rather than using WhatsApp पे जितना तेज टाइप करते हो उतना ही तेज यहाँ कैलकुलेशन भी करनी है, okay. So zeta value comes out to be 0.537 from my side, okay. And for others, those who are answering this, match whether the zeta is this one, 0.374, okay. And if this is zeta and 4 by zeta omega n is known, so from this settling time is known to us, so we can calculate omega n from this place, okay. So omega n will be 7.133, okay, radians per second, omega n, the natural frequency of oscillation, okay. And what will be the resonant frequency? For resonant frequency, you have to go to this equation, omega r is equal to omega n root 1 minus 2 zeta square, and calculating and getting 4.67 radians per second. This will be of NDT type questions, so you have to be very specific in answering. 0.67, okay. Don't try to round up according to yourself like 4.7. When it is given in the question or it is asked, so you have from this place you can have this, okay, 4.67. But when you are having NDT type, so don't go for rounding off, because it may happen that you may answer it, but it is out of the range, okay. So don't take chances over there. If it is set up to 2 decimal places, so you have to put up to 2 decimal places there, okay. I guess that it is a very basic question, and it is all about how you have to see a formula and extract basic information out of it, okay. So coming to the next set of questions, it was from settling, means time response analysis. The first question was from frequency analysis, and that means compensators and controllers, okay. And the next question is on your screen, and this question you have to solve, and it is to ask, it is from basic root locus. So it is a very basic question from root locus. Try to solve this question. Root locus is often asked. Root locus about the, you should know the basics about root locus, that whether a given root locus is correct or not. So you have to learn the properties, okay. You should know the properties of root locus, that how a root locus will be drawn, okay. So the basic properties which a root locus satisfies is that the root locus is always symmetric with respect to the real axis. A root locus is always symmetric with respect to the real axis, and p minus z number of root loci branches, okay, tends to infinity, where p is the number of open loop poles, z is the number of open loop zeros, okay. And root locus starts from k is equal to 0 from open loop poles and ends at k is equal to infinity at open loop zeros. So by these 2-3 points, you can easily manage that if a question is asked whether a given root locus is correct, so you can answer from it. Purushottam ja, answer C, okay. Yeah, it was correct. So the next question on your screen, that a forward path transfer function was given, it is given to you. HS, the feedback is also given to you. The variable parameter k, okay, which is to be positive, you have to calculate the breakaway point. So beginning from the root locus, as I told you, the root locus will always be symmetric with respect to the real axis, and all those properties you always have to keep in mind till your GATE exams, okay. After that also you can't have leniency to forget it. So the question is this, what about the poles? The poles will be at this position, -1 plus J1 minus J of 1. Okay. Poles are at this place, zeros are at this place. So poles and zeros, location cleared. Now you have for every breakaway point, what is the breakaway point equation? How to calculate it? It is dk by ds equals to 0. There's a shortcut trick. Okay, what is the shortcut trick? That dk by ds equals to 0, you can easily manage the equation for k as take minus and just write the denominator upon write the numerator s plus 2. It is a shortcut. You don't need to derive the equation of characteristic equation q of s is equal to 1 plus gs hs and calculate from that. The value of k you have to get from that. Okay, so it is a shortcut. Write k equals to negative of denominator by numerator. It will come from this also, the equation will be same, but it is a shortcut and you have to manage tricks because in GATE you have to be very quick and very responsive. Okay, so what is the value of k? The value of k is known to you. So dk by ds equals to, you have to differentiate this value. Differentiation तो आता ही होगा. Okay, आता है. So what will you do? You will first differentiate denominator multiplied by numerator minus differentiation of numerator into denominator. Okay, so what comes out? What comes out? What is the equation here? The whole dk by ds, if you calculate, it will be s square plus 4s plus 2 is equal to 0. Okay, this equation is in front of you. You have derived, you have differentiated this equation and you are getting this. So s square plus 4s plus 2 equals to 0. S equals to minus 0.58 and S equals to minus 3.414. Okay, so two value of S are coming. Which one is acceptable and which one is not acceptable? Okay, let us see. Root locus lies at those points on the real axis to the right of which the total number of poles and zeros, the sum of total number of poles and zeros must be odd. It is for root locus. For complementary root locus, the sum of poles and zeros on the right half of the S plane, on the right side of the poles and zero must be even. And for this, seeing from this place, it is 0, even, so root locus can't be that side. From this 0, if we imagine that when you are at this place, it is odd. So root locus will lie to this point. So minus 3.41 is acceptable value. Okay. So the question that find the location of the root locus, exactly minus 3.42 will be the correct, minus 3.4. Correct answer? Vikas Singh. Okay. So root locus, you have to especially manage all the properties of the root locus. What is the asymptotes at which the root locus branches tends to infinity will be 2k plus 1 into 180 degree upon p minus z, where p is the number of poles, open loop poles, and z is the total number of open loop zeros. I would like to offer you a very next set of question, that is this question. The question of it is a question of signal flow graph in which you have to calculate the matrix, okay, the state transition matrix phi of t. Anyone? Vishal Raj also, very good, very good. Omkar Nath Ojha, yes, try. The more you try, the more you get the results. Okay, perfection यहीं से आएगा, एक दिन में गेट में नहीं आएगा. Okay, so I would advise one thing, that while solving, please be comfortable or solve maximum number of questions from your virtual calculator which you have in your test series. Okay, don't try to solve those questions from the virtual calculator which you have in your mobile phones, because in mobile phones we are using our fingers. Okay, but in the examination it is mouse, through by which the input of the calculator, the calculator of the has to be input by mouse, so you will be facing a bit lag over there. So try to use on the PC or the laptop. Okay, so it is the next set of question which is offered to you. So let me tell you one thing, that after seeing this signal flow graph, what you get, x dot is, what is x dot? dx by dt. Okay, x को x डॉट से x निकालने के लिए इंटीग्रेशन करना पड़ेगा. इंटीग्रेशन लैपलास में देखें तो 1/s आता है, तो वो रूट जो है वो 1/s जो भी है वो इंटीग्रेशन के लिए जा रही है. ठीक है, इट इज इंटीग्रेशन दैट विल लीड टू x. सो इट इज वेरी बेसिक. आई नो दैट यू ऑल नो दिस थिंग्स. ओके, एंड you have to just give the answers. Very good attempts. Okay, try to solve. After seeing from the signal flow graph, okay, after seeing the signal flow graph, what we learned is try to extract the equation for x1 dot and x2 dot. Okay, mark the node points, that is this node point will be x2 dot, that is integrated with it, and this node point, at this point it will be x1 dot. Okay, x1 dot integrated will lead to x1, x2 dot integrated will lead to x2. Now you are very confident and you can write the equation for x1 dot and x2 dot. Okay, x1 dot equation comes out to be x2 plus u, the input, and x2 dot equation comes out to be minus 6 of x1 minus of 5 of x2 plus u. Okay, so x1 dot, x2 dot, ये A मैट्रिक्स आएगी अभी आपकी यहाँ पे 0 1 minus 6 minus 5, it is A matrix. Okay, plus अब ये B matrix 1 1, both where the inputs are 1. Okay, U. So A matrix comes out to be 0 1 minus 6 minus 5. For straight transition matrix, what you have to do, straight transition matrix is phi of t, that is equal to Laplace inverse of Si minus A. Okay, so A matrix came to you, Si minus A inverse. What is Si minus A? No answers till now. Please buck up. You don't have that much time in GATE exam. Okay, so it will be in about 2 minutes you have to answer. 2 to 3 minutes you take. Si minus A inverse. Take Si minus A first. Si minus A will be S minus 1 6 S plus 5. Okay, again from Si minus A inverse, it is inverse. So Any if you have to calculate inverse of matrix B, suppose, so it will be adjoint of B by mod B, and the inverse of this matrix will be, there is a shortcut again for 2 cross 2 matrix, that take the determinant of this matrix in the numerator, in the denominator, S plus 5 plus 6, okay, and again इसको यहां पे रख दो, इसको यहां पे रख दो, दोनों टर्म्स को नेगेटिव कर दो, दैट्स ओके. S plus 5 1 minus 6 and it will be S. Okay, so no confusion till this. इनवर्स के लिए बहुत ही सिंपल, डोंट गो फॉर लेंथी कैलकुलेशंस. इसको इधर रखना, इसको इधर रखना, और दोनों डायगोनल सेक्शन को आप नेगेटिव कर दो. सो द इक्वेशन विच कम्स, ठीक है, आफ्टर दिस यू सॉल्व इट and I guess the answer is C. No, wrong. Vishal Raj, try once more. The question, the answer should be D. Okay. Vikash Jaiswal, very good. So you have to be very confident while inverse Laplace transform also. You have to manage the residue. Okay, that is on the top. So don't miss that if you are doing partial differentiation. Okay. So if you are doing partial differentiation, you have to be very much aware of the terms which are of the upside, and then you have to calculate the residues. So D will be the answer for this. And now the next set of question that is in front of you, the question number 5. Try to solve it. It is a very good question, and this type of question often comes in GATE exam. Okay. See, the questions in GATE exam from control system are very, very well known, that you will be getting from steady state error, you will be getting from root locus, you will be getting from Nyquist. Okay, so you can easily predict and manage yourself or prepare yourself for your GATE exam. भैया सॉल्व करते रहना है, बैठ के देखना नहीं है. When I am solving on the board, you have to simultaneously do it on your paper. Okay, I am trying to just give you an idea or just a brief overview of the questions. Okay, for more set of questions, it will come to you from our side on Gradeup. So next set of question was, before you, the unity feedback servo driven instrument has an open loop transfer function given as K upon S plus 2. It is given that the peak overshoot, I already told you what was peak overshoot. Okay, was 35.1%. The steady state error to an input is, the steady state error depends upon the input that is applied. For type 1 system, okay, the steady state error will be A upon 1 plus K. Okay, for RAM type, steady state error will be 1 by KV. For parabolic type, it will be 1 by KA. But 1 will come at those places where the input is unit. Okay, when it is of any value, like AUT is applied, then you have to go through A upon 1 by K, 1 plus K. Okay, if it is given by ATUT, then it will be valid. Okay, so in this equation, peak overshoot, it is the response. Peak overshoot is this. Steady state value, peak time पे कितनी value? This is TP. ठीक है? Peak time पे जो response. Okay. So, see, in GATE exam you have to focus on formula more. Okay. Questions directly from the formula come in control system. MP is equal to peak overshoot value. Okay. E raised to the power minus zeta pi root 1 minus zeta square into 100. I hope that at this moment of time it is quite clear that where from this equation comes. Okay. और नहीं भी पता है तो try to generalize that, ये याद कर लो, because question often comes from this peak overshoot, and this value MP will be calculated from CTP minus C. C is the response. इन्फिनिटी पे, C इन्फिनिटी पे, response at infinity into 100. Okay, from there this equation comes. It is for standard second order equation. Okay, so it is known to you, and what was it? It was 35.1%. Okay, इसमें unknown term कौन सा है? What is the unknown term at present at this time? Unknown term is zeta. Okay, unknown term is zeta. The question which is appearing on your board, it has the forward loop transfer function of K S. GS is equal to K upon S, S plus 2. Okay, and the feedback loop transfer function was H of S is 1. So the closed loop transfer function CS RS is equal to, again try to manage it from this place, S S plus 2 plus K. सही है? Because GS upon 1 plus GS HS ऐसे कर देना है इसको, ठीक है? See, the more you practice, shortcut ऐसे आ जाएंगे. The more you practice, आपको पूरा लिखने की जरूरत नहीं है. Every now and then you have to write the whole equation and just simplify it. Okay. So it will be K upon S square plus twice S plus K. अब स्टैंडर्ड सेकेंड ऑर्डर इक्वेशन क्या होती है? स्टैंडर्ड सेकेंड ऑर्डर इक्वेशन होती है ओमेगा एन स्क्वायर अपॉन एस स्क्वायर प्लस ट्वाइस जीटा ओमेगा एन इंटू एस प्लस ओमेगा एन स्क्वायर. इट इज स्टैंडर्ड सेकेंड ऑर्डर इक्वेशन. सो फ्रॉम दिस स्टैंडर्ड सेकेंड ऑर्डर इक्वेशन ओमेगा एन एंड के, ये पता लग जाएगा ओमेगा एन एंड के, ठीक है? सो कैन वी डिड्यूस दैट के is equal to omega n square from this place, 2s and twice zeta omega n. Can we deduce again one thing, that zeta omega n is equal to 1? So zeta is equal to, what you will get from this place is zeta is equal to 1 by root k. Omega n is equal to root k. इस जगह से यहाँ पे ओमेगा एन इज इक्वल टू रूट के, जीटा ओमेगा एन इज इक्वल टू 1, सो जीटा इज इक्वल टू 1 बाई रूट के. सॉल्वेबल. इस पॉइंट से हमको जीटा मिलना था, जीटा वाज अननोन. सॉल्विंग दिस इक्वेशन एंड गेटिंग जीटा वैल्यू. ओके, पॉइंट 8 इज द गुड आंसर एंड इट इज द करेक्ट आंसर ऑल्सो. ओमकार नाथ झा, वेरी गुड. टुडे यू आर रॉकिंग. So zeta value will be 0.316. Okay. So the value of K can be calculated. 1 by zeta square is equal to 10. Okay. From this place, you landed up to this place. Okay. अब यहाँ पर आपको देखना है, it is a standard second order equation, but it is of type 1. The equation given was of type 1. और type 1 के कारण, if it is type 1, the error in this has to be due to ramp. Okay. Type 1 system में कभी भी error unit means आपकी UT के कारण नहीं होगी, स्टेप सिंगल के कारण नहीं होगी, हमेशा और हमेशा रैम्प के कारण होगी. ठीक है? There are two methods again to go forward this question right now. Okay, what are those methods? Again you calculate the value of steady state error coefficients and proceed that way. Okay, and the very next step you can do is that you calculate KV, that is calculation of coefficients. KV is equal to limit S tends to 0, S, G of S, H of S. Okay, and go by this way, and ESS will be A by KV. Why I said A? Because in answer it is given that it is 40 UT, it is not unit ramp, so it will be 4 by KV value. What the KV value? What will be the KV value coming from this place? GS HS. Okay, after you solve it, it will be 5 from this place. Putting S is equal to 0 and getting the equation, it will be 5, so it will be 0.8. Okay, then the very next which you can get it, it will be ESS is equal to limit s tends to 0 SRS upon 1 plus GSHS. That is also a step forward that you can go without calculating this error coefficient. Okay, both the ways the equation can be solved and the answer will be there. Okay, limit s tends to 0 SRS upon 1 plus GSHS. From this also the steady state error can be easily calculated. Okay, so either remember this one or go through this one. Both will give you the same answer, 0.8. Okay, both are the ways. Vikas Jaiswal, very good. 0.8 is the answer. Omkar Nath, again, very good. Steady state error is the correct. Yours steady state error value is correct. So in control system, it is common for both ECE and EE. Okay, electrical engineering and ECE. And the questions will be of this type only. Don't expect means it can be a bit tricky, but the concept has to be this only. Okay, means the equations can be quite complex, but the basic step which will be involved is that only. आना तो यहीं से है ना, steady state error थोड़ी ना change हो जाएगा गेट में, तो you have to follow these steps. The next question that I will follow is question number 6, that is on your screen, and again 30 seconds. Try to, it is a bit lengthy question because questions of this type often come in GATE, so that your time is killed in solving. Okay, your time is killed in solving these questions. Actually these are easy also, but lengthy, bit lengthy. Okay, it will consume about 2 to 3 minutes of yours. Practice calci. Okay, try to be confident. Okay, if you are answering your questions, okay, try to be confident, and once more try to revise your formula sheet, okay, as much as possible, because the questions in GATE are very directly from formula. Okay, so try to have the basic concepts you already know, because you are now in 4th year, or someone may be in final year also, 4th year, or someone have passed also. So the basic formula is had to be, तुमको याद रखना ही रखना है, तुम छोड़ नहीं सकते उसको. Okay, basic formulas had to be remembered by you, and you have to. So the question is, the open loop transfer function of unity feedback control system is given. Transfer function is known to you. The value of k such that the phase margin is 30 degree. ये अगर कोई एक means polar plot है, phase margin 30 degree, phase margin is at gain crossover frequency, the frequency at which the gain of the system, एक unity feedback, एक unity circle बना के, ठीक है, gain crossover frequency, ये जहाँ पे phase 180 degree हो जाएगा, that will be phase crossover frequency. This is the phase margin, the extra phase that may be added to the given system, so that the system reaches to the verge of instability. Okay, verge of instability means it is minus 180 degree. So by this concept in mind, you have to proceed to this question. Okay, phase margin, gain margin क्या है, -1,0 यहाँ पे आ रहा है, ठीक है. The factor by which the gain of the circuit must be, the gain of the system must be multiplied, so that the system reaches to the verge of instability. -1,0 is the instability point, and that too at the phase crossover frequency. Okay, the basic formula and the basic concept is this only. Now we should proceed for the given question. G of S is K. Okay, so in the frequency analysis, we move as S is equal to J omega. J omega plus 2, J omega plus 4. So calculating the phase of this, the phase will be minus 90 degree minus tan inverse omega by 2 minus tan inverse omega by 4. Okay, so it is given that the phase margin is 30 degree and then you have to calculate the gain. So phase margin is 180 degree plus the extra phase that must be added so that the system reaches to the verge of instability. Okay, so phase margin is known 30 degree, it is 180 degree plus minus 90 degree minus tan inverse omega by 2 minus tan inverse omega by 4. So from these all points, okay, calculate omega 1, 1.58 radians per second. Okay, omega 1 value will be calculated from this place, right, like this. So you have to do one thing. From this omega 1, what is the value, or what is the, at this point, what will be the value of k? So mod of GSHS equals to 1. Okay, from that you will get the value of k. Mod of G of j omega, h of j omega is equal to 1. This value you have to put in this equation, okay, and then calculating the mod and getting the answer. So root omega square plus 4 root omega square plus 16 is equal to 1. So k value will be 17.6. okay, 17.4, sorry, 17.4. The value of k will be this. This will be the value of k when the phase margin is 30 degree. Okay, what it is saying in the question again, that also calculate the gain margin. The gain margin has to be calculated for this value of k. The gain margin has to be calculated for this value, but the gain margin is also at the phase crossover frequency. The phase crossover frequency is this, okay, at this frequency. We started from omega is equal to 0 to omega is equal to infinity. I know it's a bit lengthy question, but you have to cope up with it. Sometimes it is bit lengthy questions are asked so that it can kill you or your patience test is done there, okay? And you have to maintain your calm throughout the question so that it may be attempted in the best possible way and the answer is correct also. Attempt ही नहीं कर देना है, answer should be the correct also, okay? So at phase crossover frequency, ठीक है? Phase crossover frequency. At phase crossover frequency phase कितना होगा? 180 degree, okay? Minus 180 degree, okay? And at this moment, इसका फेज इतना आना चाहिए एट फेज क्रॉसओवर फ्रीक्वेंसी. इसका फेज हमने कैलकुलेट किया था ये, ठीक है, -90 माइनस tan इनवर्स ओमेगा बाई 2 माइनस tan इनवर्स ओमेगा बाई 4. Phase of G omega was this. So from this equation minus 180, what comes out is tan inverse A plus B का फॉर्मूला लगा के आप इसको सब्स्टिट्यूट कीजिएगा और सिंप्लीफाई कीजिएगा. The final equation which will come is 6 of omega 8 minus omega square is equal to 90 degree. Okay. So if it is 90 degree, tan of 90 is infinity. It means that 8 minus omega square comes out to be 0. Omega PC at phase crossover frequency, the value of omega is equal to root 8 of radian per second. Okay. So root 8 radians per second, and you have to calculate the gain margin. Gain margin is calculated at the phase crossover frequency, and the phase margin is calculated at the gain crossover frequency. Again, mod of j omega is equal to 1. Okay, is equal to mod of j omega is equal to 1 for this omega gc. Okay, for omega pc, what is the value? For omega pc, it will be k upon s. It will be j omega. Okay, j omega plus 2, j omega plus 4. Take the mod and put omega is equal to omega pc is equal to root 8. जब यहाँ पे root 8 का value put करेंगे, so k value already be calculated as 17.4. Try to calculate this value. It will be again root 8 plus 4, root 8 plus 16. And this value of j omega at this phase crossover frequency will be 0.36. Okay, when it is 0.36, अब इसमें कितना मल्टीप्लाई कर दिया जाए कि ये -1 पे पहुंच जाए? That is actually the phase, that is actually the gain margin. Okay, so coming to the basic gain margin equation, A is the correct answer. Anand, sorry, day. Okay, A is the, again, Soumya also answered correctly. It is A is the correct answer. So for gain margin, okay, 20 log 1 by mod of j omega. So answer will be 8.2 dB, 8.82 dB. Okay. Good, correct attempts. You have to be very much clear that if it is given out the gain crossover frequency, the gain has to be 1, which we substituted the value here. And if it is asking about the phase crossover frequency, then we have to calculate the gain margin, and the value is -1, 0 point. Okay. Polar plot starts from omega is equal to 0 to omega is equal to infinity. So you have to be very much familiar with all these. Okay. Now the last question that I want to discuss with you all is of the Nyquist. It is a very important topic and is often asked. Means this time also one question at least you will get from this topic. It is the expectation. Don't say that I have set the paper. So the Nyquist question is on your board. With lots of more sessions, more live sessions to be conducted, you have to make your presence over there. Okay, and we will be back with very good set of questions. You have to practice more and more questions. Give your mock test wisely. Okay, or the questions or the topics like chapters like microprocessor which you haven't studied. अब 1 नंबर का आएगा, उसके लिए फिर से अब तो पढ़ने की ज़रूरत नहीं है. ओके, अगर अभी तक नहीं पढ़ा तो उसको तो छोड़ दो. ठीक है. And attempt more and more number of tests. Okay, we will also provide you more and more number of questions from our platform. So you have to attempt. B. No. Oh, for this one, for C. Yeah, B is the correct answer. Okay. Abhigyan is having Gyana. Abhigyan is performing well. As the name suggests. Okay, it's good. So the equation which is of Nyquist, I'm going to make you think that why it is so. Suppose it is a Nyquist plot which was given omega equals to 0 to omega is equal to infinity for polar plot. For polar plot starts from omega is equal to 0. Okay. Omega equals to infinity. From the point omega equals to 0 to omega equals to infinity, the value of phase will be minus 90 degree into type to minus 90 degree into P minus Z, where P is the number of open loop poles and Z is the number of open loop zeros. Okay, so by seeing the polar plot itself, okay, you can very easily check that type of the system is 1. Why type is 1? Minus 90 degree into type 1, it is minus 90 degree, it is minus 180 degree, it is minus 270 degree. Okay, so going in anti-clockwise direction. Okay, going in anti-clockwise direction. So what you found? You found that the type of the system is 1. Okay, at this point it is given that it is, I will write here, minus 1 comma 0. Minus 1 comma 0 is in this half semicircle. Okay, अब polar से Nyquist कैसे जाना है? Just try to have this. I hope so you are getting. ठीक है. How many encirclements will be there? What will be the encirclements? Actually, I am trying to cover the basic concepts from this question, so you need not to means कोई दूसरी चीज देखने की जरूरत नहीं पड़ेगी. Actually, as only one session is there, so I will try to cope up with all those things, okay, which are coming. So number of half encirclements कितने होंगे? Number of half encirclements will be minus number of half encirclements which will come will be type. ठीक है, जितना टाइप होगा उतने हाफ सर्कल्स बनेंगे. ओके, जितना टाइप होगा उतने हाफ सर्कल्स बनेंगे. ये वापस पहुंच गया. यू हैव टू क्रिएट अ मिरर इमेज ऑफ इट एंड अगेन हाफ सर्किल कितना? एज द टाइप ऑफ द सिस्टम. हाफ सर्किल कितना? एज द टाइप ऑफ द सिस्टम. यहां से शुरू हुआ, पोलर प्लॉट वाज दिस, and again the Nyquist plot for this was ending at this. Half circle इसको जोड़ना है. ठीक है, half circle will be, number of half circles will be type of the system. Type of the system is 1. Number of half circle will be 1. I hope you are getting it. Okay, so for the instability point of view, I will try to clean this. Stick to this question. I will completely cover all the concepts from the Nyquist. Okay, if it comes, then very easily you can manage all the questions from this place. So it will be minus 1 comma 0. अब यहां पर एक चीज देखना है कि n equals to p minus z. What is this n? N is the number of encirclements of point minus 1 comma 0 in anti-clockwise direction. Don't ever confuse with clockwise and anti-clockwise. N is in anti-clockwise direction. Okay. P is the number of poles, number of open loop poles on the right half of the S-plane. If the equation is given to you, so number of poles that were on the right half of the S-plane. Okay, so in this question which is given to us, it is showing that 0 open loop poles lies on the right side, So P is 0. P is again the open loop poles on the right side of the S plane. Z is the total number of poles or total number of roots which causes instability to the system. Okay, which causes instability to the system. So what is N? N is the number of encirclements of the point -1, 0 in the anti-clockwise direction. It is clockwise? I guess it is clockwise. It is correct also. One clockwise direction. It is not encircling. ये भी नहीं encircle कर रहा है. Again the bigger circle which is encircling -1, 0. So एक encirclement clockwise direction में -1 होगा. दूसरा encirclement clockwise direction में -1 होगा. So value of N will be -2. So N will be P minus Z. N value is -2. It was encirclement in anti-clockwise direction. It was encirclement anti-clockwise direction, but in this equation it is in the clockwise direction. So minus sign was considered. P value is 0. No poles on the right half of this plane. -0. So it will be Z is equal to 2. 2 poles or 2 roots will cause instability to the system. Okay, that will be in the right half plane. Okay, so I hope that you enjoyed the session, and I also prepared these set of questions that were easy and often asked in your exams. The questions for Nyquist are very common and will occur oftenly. Okay, these questions will be asked again and again in your exam. So I wish that it is quite clear to you, and for more set of questions you should follow Gradeup. And one thing more, the link of the test series, okay, and the practice sets and all those materials will be provided to you in the comment section. Okay, the link will be provided in the video itself, in the description section below, and also in the comment section you will be having it. So try to practice more number of questions, prepare yourself well, give mock test, have confidence. If you don't try, or if you don't try that hard, then how will you get the proper results? So you have to be patient while answering the paper. In entity type, plus or minus, you have to be very much attentive. You don't have to round off any digits. If it is saying that correct to 2 decimal places, then you have to write correct to 2 decimal places without any rounding off of the question answer. Sorry, okay, without any rounding off the answer. अगर किसी mock test में या किसी भी full length test में number कम आते हैं, you have to analyze the portions where you have to put in efforts. Always do one thing. 4, 5 सब्जेक्ट्स के क्वेश्चन आप जो है पर डे जो बुक मार्क किए रहें, जो कि अच्छा हो टेस्ट सीरीज में, जो कि अच्छा आपने देखा कहीं पे, जो भी अच्छे कॉन्सेप्ट्स देखें, आप उनको फॉलो कीजिए पर डे. उनको मतलब हर 2-2, 3-3 दिन पर उनको देखते रहिए. ऑलवेज डू वन थिंग, फॉर्मूला शीट अपनी बनाइए एंड गो थ्रू इट. इट इज रियली गोइंग टू हेल्प यू आउट. ओके, because आपने एक बार बना दी, it will help you in all the exams, all the coming exams. It will be helpful for you. Okay, so do one thing, have formula sheet, revise question and answer from the bookmark which you have followed, okay, with the test series. Link comment section में और description section में आपको link मिलेगा Gradeup का. Please go through those questions. Those are actually very good set of questions. Our team prepared, okay. And if a question is asked before, and you come across it, so don't say that the question has appeared somewhere and the question you want always new. If the question has appeared somewhere and you have to get some concept out of it, and the concept has to be remembered, okay. So for Nyquist, and again one topic I think that I didn't manage to complete at this place was signal flow graph. It is very easy, okay. Try to cope up with the signal flow graph, and the question comes directly from the Mason-Gain formula. So Mason-Gain formula also, you be aware of it, okay. And in control system, that was it. And the control system questions are directly from formulas. So be very careful in the formulas, rise time, delay time, peak time, and in the frequency analysis also, maximum phase, okay. Phi is equal to sine inverse 1 minus alpha upon 1 plus alpha. Okay, maximum peak of MR is equal to 1 by 2 root zeta 1 minus zeta square. You have to go through all these questions to attempt your best in the GATE examination. Okay, all the very best. Prepare hard. Okay, and I hope that you will come out in flying colors. Okay, follow Gradeup. Thank you.